Hello again. We are taking a look at doing some BigQuery monitoring because we want to control how much spending we're doing on this data engineering project. And for this project, we're running with the on-demand compute pricing. So every unit of data that we're processing, that is what we're getting billed for. And you can see here the pricing structure is $6.25 per terabyte. Before we hit that pricing structure, you can see here that the first terabyte of processing per month is completely free. And I'm all about that free stuff. So I want to stay within that free tier, and we're going to build some observability tools to make sure that we're staying within those limits. So we're going to make a Plotly Dash application, and we're going to deploy it onto Cloud Run. And we're going to get some visibility over how much data we're processing on a job-by-job basis. So we'll start off with jumping into our Dash application, and I'll show you how it's configured at a very high level. So you can see here in our BQ monitor, we got our Dash application here. I'll just quickly jump into it to show you what it looks like. And I'll just quickly skim over at a very surface level what's going on to briefly explain how this application is structured. You can see that we got some SQL queries here, which are being parsed into the application, and it's pulling information out of the information schema to get information about SQL jobs being processed against our project. And we can see which users are executing against the project, how much data they're processing, and how much slot time they're executing if you want to optimize for capacity pricing. We also got a user level aggregation. So we take all of those jobs and we aggregate them down to the user level to see how many queries they're running, what is the total data they're processing, and then we can make some decisions over how to optimize our BigQuery processes. So that's how we're extracting the data. We query that data and we load it into this load data function, which returns us a pandas data frame. And using that data frame, we'll apply some transformations and we'll split it up and spread it around to different KPI tiles. We'll put the data into drop-down menus, and we will be visualizing that data in the application. So you can see here when we first initialize the Dash application that we load into two different data frames for different purposes. And then right after that, we initialize our Dash application. And from this point forth, it's just going to be like 99% HTML. You're creating all of your HTML divs, and you're using callbacks to insert data dynamically into those various elements. So I'll just skim through the layout that we've got presented here. And that's pretty much the end of the layout. You get down to the bottom of the application, and you can see that we're starting to implement some Dash callbacks. And what a Dash callback is anytime you make a change to your application via drop-down menus or date pickers, it will activate this callback and it will run your function in order to refresh your data. So you can see here we've got some inputs here for date ranges and drop-down filters. So anytime we pick something there, it's going to activate our refresh data function, and we will be able to see a revised subset of data that was initially loaded. And I'll skim over the refresh data function since there's a lot of transformations happening as you are applying different filters. But you can see that we're changing different date ranges for these data frames. We're creating some KPI metrics. And then we're creating some dynamic KPI tiles and displaying them inside these HTML div containers. We're visualizing data in the chart, and additionally we are creating a table that we're going to later present inside the HTML as the data is being refreshed. And additionally we also have one more further callback, which is monitoring the state of the tabular data that we have on Dash. So anytime that we update the data on Dash, it will update the subset of data that we want to be available for download. And as soon as you click download, that subset is going to be available to the user through the client. And yeah, that's pretty much the Dash application in a nutshell. I will show you how we're deploying it onto Cloud Run. And for that, we need to build some kind of Docker image in order to get the deployment going. So we're going to go into Docker, our Docker configuration. So going into our BQ monitor, you can see we got the same kind of deployment setup that we had previously, where we have the Dockerfile and the variables file. Going into the Dockerfile, it's the same sort of image setup as the previous images, with the exception of making a few more directories for our assets in our Dash application. And we're doing the same old cringe curling stuff in the image, but we'll get to fixing that a bit later. Still on the to-do list. But the main thing that you should be concerned with is this entry point. Typically, when you're deploying some kind of Python application and you want to execute it, you specify the command Python and the name of the script. That's not going to be the case here. Since we're running a service on Cloud Run, for our entry point we need a WSGI web server to be running in the background, so you can handle HTTP interfaces in parallel with running our data processing at the same time. And for that, our WSGI server is going to be GUnicorn. So in order to set the entry point, we specify GUnicorn to activate that web server. And it's going to be listening to all of the network interfaces on port 8080. And since our Python script is called main, we will be specifying the word main here. And we want it to target the server object inside our Python script, so you can serve the application. And yeah, that's pretty much all you need to get this service running, theoretically. So we'll exit out to this Docker container, and then after you build that Docker image, you just need to build it locally, and you can push it into artifact registry, as you've seen in episode 3. So at that stage, you have your Dash application designed. We have our Docker image deployed to artifact registry. We just need to deploy our instance into Cloud Run. And for that, we're using Terraform. We're going to go into our main Terraform file to show you the resource that we're pulling up. So you can see we're creating a Google Cloud Run service. We're calling it BQ Monitor Dash, and we're applying a service account, and we're pulling that Docker image that we created earlier. And that's pretty much all the configuration you need to pull up a Cloud Run service. From that point on, you can just simply Terraform apply, and it's going to pull up your resource onto GCP. So now that we got everything set up and ready, we can go into GCP and check what that resource looks like and see how we can access our Cloud Run service. So you can see we have our BQ Monitor Dash application right here. We can click into it and you can see that we have a URL here. Typically, you can copy paste this URL into your web address bar and you'll get access to the application. Although in this current setup that I have no way of passing through my IAM credentials in through this HTTP request that's being made. You'll see here in a second that we get a 403 after attempting to access the application. In order to have this set up correctly, you actually need to set up an identity-aware proxy, and additionally you need Google Workspaces in order for this application to work internally. However, I'm not willing to spend 12 or 13 pounds a month to pull up a service one time and then just have that running. So we're going to do it the jank way, since we don't want to spend $1 billion running a side project. And we're going to do that through the use of a proxy. Assuming you have your Google Cloud SDK set up correctly and it's connecting to GCP using your user credentials, we can borrow those CLI user credentials to proxy ourselves onto the Cloud Run service. And I've designed a little shell script in order to give us access in that manner. We're going to go back to our dash directory inside our chest analysis project. Inside the BQ monitor, we have this gcloud directory that we created. And we have this run-application shell script. So we got a gcloud command here that runs a proxy server through our localhost onto our BQ monitor dash application, and that will give us access. It will pipe through the CLI credentials through this proxy, and we'll get access to the application. So we'll just run that shell script and we'll jump into our dash application. So running the shell script now, and you can see here our localhost address is here, running on port 8080, and it's proxying to our application here, the one we displayed from Cloud Run. So I'm going to take this localhost address and paste it into my URL bar, and we should be able to access our dash application through our Cloud Run service. And it's going to take a moment to load since it's pulling up a container from zero. And once it's initialized, we should be able to see the application. So you can see we got a very simple design here. We got some date range filters, we got some user email filters, and we got a metric filter in order to get a different visualization appearing on our chart. We additionally have some KPI tiles, so you can see how many users are on our platform, how many queries have been executed within this date range, what's the average data being processed, what are we being billed for on average, and what is the percentage we are away from hitting the free tier end cap. And this KPI is going to be critical for giving us a view in terms of how intensively we want to be running data pipelines in BigQuery. Since the closer that we're getting to 100%, the more we'll be inclined to be scaling back how often we're running our transformation processes. You can see that we have our visualization here. If we change the date ranges here, it's going to get automatically reflected in the visualization. Let's widen that range a bit more, and let's shorten it a bit as well. Yeah, we can also select which metric is appearing in the visualization. So for example, currently we're looking at how many megabytes we're being billed for. In contrast, we can also see how much data we're processing, which is going to be slightly different. Since we're processing a very low volume of data, the figures are going to be quite low here in contrast to the data we're being billed for. Every time you execute a query on BigQuery, it's automatically going to bill you at a minimum of 10 megabytes per query. So it's worth keeping that in mind if you're running lots of like 1 kilobyte jobs. So just bear that in mind. Because if you run like thousands of those, that's quickly going to add up and it's going to start costing you money. Yeah, and we can also look at how many queries were processed in those various days, and you can see the distribution here. And additionally, we also have this tabular view of the data, which gives us low-level details in terms of which users are running which particular jobs, how many bytes they're processing on those specific queries, and how much slot time they're consuming when they're running those jobs. And you can make informed decisions over how to optimize your BigQuery processes if you see something exceeding a certain threshold. The tabular data is also paginated, so we can flick through the different bits of information and just to get a glance of what's going on in our system. And with the date filters that we've applied here, we will be able to download a subset of our detailed information in this download table button. So if we click download table, it's automatically going to go into our downloads folder. We can go ahead and click it, and it's going to get imported into our Excel document where you Excel fiends can start analyzing your data here. And that's pretty much it in terms of BigQuery observability. We can see how much data we're processing, and we can see how far away we are to hitting the free tier cap. So hopefully we can keep our BigQuery costs down to absolute zero. And yeah, that's pretty much it, and I'll see you guys in the next one.